Hello, I'm Michelle Crummell, and in this video, we're going to be brushing up on our calculator skills and hopefully learning some useful tips and tricks that will help you work more efficiently with your graphing calculator. So I'm using the TI-84 plus CE graphing calculator, but I'm pretty sure all of my button presses are going to be the same if you're working with a regular TI-84 or a regular TI-84 plus, and mostly the same if you're working with a TI-83. Before we begin, let's reset our calculators just to make sure that what you're seeing on your screen is going to match what I'm seeing on mine. So to reset the calculator, and you can do this at any point, you're going to hit second mem, or the plus key, and then we want to choose number 7, reset, so you can either arrow down and hit enter when your cursor is highlighting the word reset, or you can just press the number 7 to select that. Then we want all RAM, so I can hit the number 1 or just press enter, and then reset. So either arrow down over reset and hit enter, or just press the number 2. So now I have reset the calculator. Let me just quit. So second mode is going to quit. Anytime you see the little words in blue here, to activate that command, you hit the second key, which is also blue. So if I want to quit, I hit second and then the mode key, which is actually activating quit, not mode. Okay, so that just, if you quit, it just takes you back to your home screen, which for me is blank at the moment. And as I work through these different questions and I'm pressing different buttons, you're going to see my key press history appear over here on the right. So if I'm getting a little bit ahead of you, you can look there to see what I pressed on my calculator, or if you need to pause the video at any time to catch up, please do so. So I'll periodically clear this key press history just so that it's a little easier to look at and follow along with what we're doing. So let's look at our activity, and what we're asked to do here is to sketch an accurate graph of the function f of x equals tangent of e to the x squared plus x plus 1 on the closed interval from 0 to 1. We also want to label all intercepts and asymptotes on the given interval. So it does say sketch the graph, but we don't want to just sketch it on the calculator. We want to be able to sketch it on a piece of paper and make sure that we can label all of those key features of the graph on our paper and pencil sketch. So the first thing we're going to do is enter our equation into our equation list. And to get to your equation list, you're going to press y equals. So now we can just type in our equation. I want the tangent of, and let me just pause here for a moment and say, anytime you press the sine button, the cosine button, or the tangent button on your calculator, so these 3 buttons right here, sine, cosine, tangent. Anytime you press those buttons, you want to pay attention to what mode your calculator is in, because you will get different results if you're in degree mode versus radian mode. So for calculus, we always want to be in radian mode. There may be a few exceptions to that, but for the most part, I would say 99% of the time, we are working in radian mode in calculus. So students who are taking physics and calculus at the same time will often have to switch back and forth. In physics class, you're usually working in degrees. In calculus, you're working in radians. So I can just quickly look up here on my display and see that I am currently in radian mode, which is what I want. If I needed to change that, I would press the mode button and I would arrow down, and right now I'm in radians, so that's good. Or you can highlight degree if you want to switch to degree mode and then press enter. So I'm just going to go back to my y equals where I was and continue typing my equation. So my equation for f of x is the tangent of, now I have e to the x squared, so second, and then on the ln button above that in blue, you see e to the x, and that's what I'm trying to activate here is e to the x. But I want e to the x squared, so then x squared, and my exponent is x squared, e to the x squared. Yeah, just e to the x squared. So now I need to move my cursor to the right to come down out of that exponent and enter plus x plus 1. So you want to be careful there and make sure that you don't have x squared plus x plus 1 all as the exponent of e. It's just e to the x squared. And then you come down plus x plus 1 and close your parentheses. And the size of the parentheses should match for that pairing right there. So number 2 in our activity says use Zoom 6 to graph using a standard window. If you just press graph, then your graph will display using whatever window settings are currently in your calculator. Now we reset our calculator, so it would be okay if we just pressed graph. We'd all see the same thing. But if you hadn't reset your calculator, then our graph would display using whatever window settings you already had in there. But if you ever want to just quickly start with a standard window, if you're not sure what your window should be, I like to start with Zoom 6. It's a standard window. It graphs from -10 to 10 on both the x-axis and the y-axis, counting by a scale of 1. So Zoom 6, and that is often sufficient. Now that graph, doesn't look very great. Looks a bit strange. And on your handheld calculator, it probably didn't graph as quickly as it did for me here on my emulator. So the next tip I want to show you, and it may be difficult for me to show you here because mine did graph so quickly, but oftentimes what happens is when you're graphing something with an inappropriate window or just not an ideal window, the graph moves very slowly, and students often think that they have to sit and wait for the entire graph to complete, because if you try pressing buttons like the numbers or clear or delete or mode, and those buttons on your calculator, nothing happens. It just, the calculator is still thinking and it's still continuing to graph. But this tip I want to show you, and this is number 3, is that you can always press the on button to interrupt a graph. So if your calculator, if you're getting those 3 dots in the upper right hand corner that are just spinning, your calculator is thinking, or it's chugging along trying to produce this graph and it's taking a long time, and you're trying to press buttons and it's not responding, you can always just press the on button. That will interrupt or break whatever process is currently happening. So I'm going to try this one more time and see if I'm quick enough, I might be able to interrupt it, but mine did graph fairly quickly. So let's try this again. I'm going to hit graph on. Oh, I didn't make it in time. I can probably slow this down. Let me see if I can slow this down for me here. But hopefully you're seeing it on your handheld calculator, that if yours is graphing slowly, just press the on button and it will interrupt it. I wonder if I can change this value here to slow my calculator down. Let's just see what happens here. It may not like that. Oh, that completely changed my window, so that wasn't helpful. Let's do Zoom 6 on. Sort of got it again. It's not going to work out very well on this example because my emulator is running on my computer and it's very fast. But again, hopefully if you're following along with your handheld calculator, you'll see what I mean here, because I do think this is one of the most valuable tips that we're going to go over today, is using that on button on your calculator to interrupt the graphing process. So we're not quite finished with number 3. It also asks us to adjust our window. And this notation here is indicating that the x values should go from 0 to 1. And then we want to estimate the range for f of x. So let's clear my history because we got a lot of button presses going on there. Okay, so I'm going to hit window, and we want to change the x min and x max. So the x min will be 0 and the x max will be 1. And we weren't told what to make the scale, so I'm just going to leave the scale 1 as is. And we are going to hit graph, and then we want to estimate the range of the function f of x. So I want you to look at this graph, and based on what you see here, what would you estimate the range to be? So just think about what you're seeing in this window only. What would you estimate the range of this function to be? Not the whole function, just on the interval from 0 to 1. Only the range on the closed interval from 0 to 1. What do you think the range is? So I would expect you to give me an estimate of somewhere around -2.2. I'm looking at this point over here because our interval starts at x equals 0. So this is -2 point something. We're not quite sure what, but maybe -2.2-ish, right? And then it seems to be going up, 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 up. And we didn't quite get over to 1. Well, you can see there's a little gap there at the edge of the screen. So this graph is probably going to continue to shoot up. It kind of just depends how you're thinking about it. You might say 10 as your upper value for your range, or you might think, no, that's going to be a really high number because the closer you get to 1, it's just going to keep going up. So I would expect you to either say negative 2.2 to 10-ish, or maybe 20, or even negative 2.2 to infinity, depending on the way you're thinking about this, as the range of this function on this subdomain from 0 to 1. So let's look at step 4. It says readjust your window. Instead of graphing x from 0 to 1, let's graph x from 0 to 1.2 and then see what we think about the range. So we'll hit window and we'll leave the x min at 0, but we're going to change the x max to 1.2. So we're just bumping it over a little bit from 1 to 1.2, and let's graph. Now we're seeing some really different behavior than what we saw when we stopped our interval at x equals 1. So clearly there's other parts of the graph that we weren't seeing in that limited window view. So now estimate the range of f of x. Now this question, it's not quite as specific, but let's still say on the interval from 0 to 1. So on the interval from 0 to 1, what do you think the range is? Or we can also extend that and just say, no, f of x in general. Like if we consider all of f of x on its entire domain, what do you think the range would be? So it's difficult to know for sure based on what we're seeing on the calculator here. Clearly the range, well, first of all, let's just limit ourselves to the closed interval from 0 to 1. Let's go back to that, because from 0 to 1, before we said the range was maybe negative 2.2 to infinity, or maybe not quite as high as infinity, but a large number. And now it's still, I don't know that I would change that estimate. It still kind of looks like that because this little tick mark right here represents 1, an x value of 1. So yeah, we have function values that are less than negative 2.2, but it's unclear if that happens. I mean, it looks like that only happens when x is bigger than 1. So if we're still going to limit ourselves to the interval from 0 to 1, then you still might answer the same way. You might say, well, the range from 0 to 1 is negative 2.2 to infinity. Or negative 2.2 to 20 or something like that. If we extend this to just all of f of x, let's not limit ourselves to the closed interval from 0 to 1, just all of f of x, what do you think the range is? Then you would probably say negative infinity to infinity, because the graph looks like it just keeps on going down here, down, 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 down towards negative infinity, and up here towards positive infinity. Okay, so any of those answers are fine, because you really can't give me a definitive answer yet. That's kind of the point of this activity, is we're kind of looking at some of the ways that the calculator can possibly be misleading, or not necessarily misleading, but just unclear, and why it's important to be able to use the calculator in different ways. Maybe not just rely on this one graph. What else can we do in the calculator to help us figure this out? Okay, so question number 5, in what way is the calculator output misleading? Well, we still haven't really answered the question yet, but we did see that your viewing window can determine how you describe that function. So the viewing window only shows a small portion of the graph, but the graph might behave in unpredictable ways outside of that viewing window. So we always want to be careful in thinking about the interval that we're working on and our window settings when we're looking at a graph. Okay, number 6 on our activity sheet. In order to sketch the graph, we need to determine the coordinates of the endpoints, because remember, if I go back up top, we are only interested in sketching this graph on the interval from 0 to 1. That's the goal of this activity. On your paper, I want you to be able to sketch f of x from 0 to 1. So in order to sketch that graph, we need to determine the coordinates of the endpoints. What's the value of the function when x is 0? What's the value of the function when x is 1? So we can include that in our sketch. So first let's find f of 0. And I'm going to clear my key press history here to do this. And I'm going to show you 4 different ways you can find f of 0 on your calculator. And you can decide which one you like best and use that one. Or you might want to mix it up and use one method sometimes and use a different method other times. One way to find f of 0 is to use the F4 menu. And the F4 right here above the trace key is colored in green. So to activate F4, you're going to hit this green alpha key. Okay, so it's alpha, F4, but you're actually pressing the trace button. And that brings up this like shortcut menu here. We want Y1. Now Y1 is already highlighted, so you can just hit enter, or you can press the number 1. And that brings up Y1. So Y1 is referring to the function that is stored in our equation list for Y1. Now we want to find f of 0. So in calculator speak, that would be Y1 of 0. So I'm going to type the parentheses, 0, parentheses, and hit enter. And the calculator recognizes this as function notation. That's f of 0 because Y1, if I look at my equation list, this is the function in Y1. It's just not called f of x like we normally might call it f of x. The calculator is calling it Y1. Okay, so let me go back to the home screen, and now we can see that f of 0 is negative 2.185039863. That's probably rounded, right? But that's a pretty close approximation of that value. So let's look at another way we could have found f of 0. Let me clear my key press history. And I could have done this sort of the long way of getting there. The F4 menu was the shortcut way of getting there. Let's do it the long way. If you have an older calculator, if you have a TI-84, the F4 method is not going to work for you. So you would do it this long way. You would hit vars and then arrow right to highlight Y vars. Vars stands for variables. And then we want to choose function. So you can either press number 1, or since 1 is already highlighted, you can press enter. And then we want to choose Y1. So I'm going to hit 1, or again, you could hit enter. And that, took us to the same place that F4 did. And then in parentheses, 0, enter. And we can find f of 0 that way as well. Another way to get f of 0 is using our table. So I'm going to hit second graph, which will take me into the table. Table's in blue, so to activate that, we hit second and then the graph button. And right away, it's highlighting 0. So f of 0, I can see is negative 2.185. Now that doesn't display as many decimal places as I had on the home screen, but I can just arrow over that value, and we actually get more decimal places displayed here than we did on our home screen. So this is another way to get f of 0 with a high level of accuracy. And the final way I'm going to show you to find f of 0 would be using the graph. So let's go back to the graph, and I'm just going to hit, let me clear my key press history. I'm going to hit trace, and then the number I want, 0, and then enter. And my cursor will jump to that point where x equals 0, and I can just read the y coordinate down here. Y equals negative 2.18504. Again, I'm not getting as many decimal places as I did on the home screen or in the table, but 5 decimal places is usually more than you need in terms of accuracy. So that's another good way to evaluate the function. Okay, next question, number 7. Find f of 1 using one of the methods above. So I'm going to quit and use the method that I prefer, but you can use any of those 4 methods. I prefer the F4 method. That's the fastest for me. So alpha F4, 1 for Y1, and then in parentheses I enter my X value, hit enter, and there we have Y of 1, or F of 1, is negative 169.6952666. So this might be surprising. Remember what our graph looked like. The negative 2.185 is not that surprising because that's what it looked like on the graph. It looked like when x was 0, y was about negative 2.2. So that's not surprising. But f of 1, that is a little surprising to me because that's not what it looked like on the graph. We've got y of 1 equals negative 169.695. So about almost negative 170. So let's go back to the graph. What we're saying is that when x is exactly equal to 1, y is about negative 170. So clearly my window doesn't go down that far, and that's why I'm not seeing that displayed in my window here, but that is what's actually happening. So that's going to be a little bit tricky for us as we're trying to sketch this graph. We want to make sure because it is a closed interval, that we're including that right endpoint when x is 1, there should be a point on your graph at negative 170. So something's going on here because it looks like to the left of 1, we have positive values, but at 1, we have a very low negative value. So there's a break or a jump somehow in the graph right here. So let's analyze this a little bit more and try and figure out what exactly is going on here. So number 8, we're going to work with our table. It says to enter the table setup. So table set right here we see in blue. To get there, we're going to hit second window. That's going to take us into our table setup. And we are going to change this. By default, your independent variable is on auto, but we're going to change it to ask. So you want to hover over ask and hit enter. Don't do that with your dependent variable, just do it with the independent variable. We're changing that independent variable to ask. Now we're going to go into the table. So second, and then the graph button takes me into my table. So normally when you go into the table and it's on auto, you'll see in the first column 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can scroll up and down in your table to get different values. But when you put it on ask, you're not going to see any values displayed there until you actually type them in. So you get to type in, you get to ask for the values you want. If you want f of 0, you would just hit 0, enter, and there's our f of 0. If you want f of 1, you can type in 1 and hit enter, and there's our f of 1. So this is really useful if you need a number that's not like 0, 1, 2, 3, 4, if you need some other value, or if you need several values that are not evenly spaced, like what we see in question number 8. It's asking us to find f of 0.9, 0.99, 0.999, 0.9999, and so on. And so I can, here, let me just delete what's already there and just type what I need. So I need 0.9, enter, 0.99, enter, 0.999, enter, and then 0.9999, 0.99999, and then finally 1. So let's talk about what we're seeing in the table here. So this looks a little bit strange. I did not type the number 1 in twice, but we see the number 1 displayed here twice, and that's just round off error in your calculator. If I highlight this number, you can see what I entered was 0.99999. Even though it's displaying it on the screen as 1, it's not really 1. It is 0.99999. So you can always highlight a number in your table to get the exact value, or at least the most accurate value that the calculator can give you there. And if I scroll down and highlight over this one, it is exactly 1. And those y values are different. So there is a difference there. So what is happening in our table here? Well, we can see that the y values switch from positive to negative somewhere in between x equals 0.999 and x equals 0.9999. So that kind of matches the behavior we were seeing on the graph there. We're going from a really large positive value to a really low negative value. And that's going to happen somewhere between 0.999 and 0.9999. So there's a break in the graph there, and it looks like there's a vertical asymptote there. A vertical asymptote somewhere between these two x values. So that's how I would respond to question number 9. What does the table suggest about the graph of y equals f of x? It suggests that we do have a vertical asymptote somewhere between x equals 0.999 and 0.9999. Now, just looking at the graph, I don't think anyone would come up with that answer, right? It looks like there's a vertical asymptote at x equals 1, and that's what I would expect most people to say. But it doesn't occur at 1. It occurs a little bit before 1. It occurs somewhere before 0.99999. So it happens really close to 1, but not quite at 1. So using the table can really help us analyze what's happening on the graph here. Okay, let's clear our key press history and look at question number 10. Solve the equation e to the x squared plus x plus 1 equals pi over 2 graphically on the closed interval from 0 to 1. And we have some suggestions here on how we're going to go about doing that. So I'm going to press y equals to go back to my equation list. And because we are not solving the tangent of e to the x squared plus x plus 1, I'm going to temporarily hide what's in y1. I don't want to delete it because we're going to need to use it again later, and I don't want to have to come back and retype it later. I'm just going to hide it. So to do that, move your cursor over the equal sign and hit enter. And then when you come down, notice that it is like deactivated. That equal sign is no longer highlighted. When I start typing in something, let's start typing in e to the x, you can see now the equal sign is highlighted in black. That equation is now active, and when you press graph, it's going to graph this equation for you. But y1 is currently inactive, so it will not show up when we press graph. Okay, so when we solve an equation graphically, we can graph the left-hand side separately from the right-hand side, and then we're looking for a point of intersection. So I'm entering the left-hand side of the equation, which is e to the x squared. Bring your cursor down, plus x plus 1. That's the left-hand side of my equation. The right-hand side of the equation is pi over 2. So second, and then the caret gives me the pi symbol, divided by 2. So there I have y2 and y3, left-hand side, right-hand side. We want to graph those and see where they intersect. Now it's asking us to solve on the interval from 0 to 1. So I'm going to go back into my Windows setting, and I can change it instead of 0 to 1.2, change it from 0 to 1, or you could leave it 1.2, but just don't use any points of intersection that are more than 1. So I think it's safer to go ahead and change the window. I'm going to clear that and just change it to a 1, press enter, and then let's look at the graph. So what I'm seeing on the display here is the left-hand side, right-hand side. And if you're not sure which is which, I mean, if you think about the equations you entered, it should be pretty clear that the horizontal line is the constant, so that's the pi over 2. But if you're not sure, you can hit trace and then look where the cursor is. And it's also color-coded. So the red equation is y2. It tells me up here. The red equation is e to the power x squared plus x plus 1. You can arrow down. The black equation is the y3 equals pi over 2. We're looking for a point of intersection. So it doesn't look like they do intersect. If they do intersect on this interval, it would be right over here. It's little, we're zoomed out far enough that we can't really tell what's happening there. But it doesn't look like they intersect. One way we can check is to ask the calculator to intersect these two curves for us. So we can hit, and let me clear my key press. We're going to hit second, calc, and then number 5 is intersect. So you can either just press the button 5 or scroll down to 5 and hit enter. And then it's asking, what's your first curve? So yeah, the red curve is my first curve. I'm going to hit enter. And then what's your second curve? Yeah, the black curve. I'm going to hit enter. And then do you want to guess the intersection? Yes, so hit enter. And we're getting this error that says there's no sign change. And so there is no point of intersection on the interval from 0 to 1 that we're working with. So let me just quit out of that. They do not intersect on the interval. They do not intersect. So let's move on to question number 11. Now it wants us to solve the equation, same left-hand side, e to the x squared plus x plus 1, but the right-hand side is now pi over 2 plus pi. So let's come back to our equation list and change y3 instead of pi over 2. We'll make it pi over 2 plus pi. Now what happens to a graph if you add a constant at the end of the equation? Think about that for a moment. In terms of transformations, if you were to add 1 at the end of an equation, how would that affect the graph? We're adding pi, which is also just a constant. So it should shift that graph up. So let's hit graph and see what our situation looks like now. And it did, in fact, move that horizontal line up pi units higher. So now it looks like they do intersect. Again, it's a little hard to tell, but if they do intersect, it's going to be over here on the right-hand side. So let's go ahead and intersect this again and see what we get. So second calc, 5, and then you can just hit enter, enter, enter. It's pretty quick. And they do, in fact, intersect. They intersect when x is 0.9990834. And I was going to say coincidentally, but actually it's not a coincidence. that is a number between 0.999 and 0.9999. Is that where do I have enough nines there? I think so. That's where we said we had a vertical asymptote, right? So this is an important solution that we're looking at here. Number 12, store the solution in A. So let's talk about storing your solutions. Whenever you intersect two graphs, actually, let's go into the calc menu for a moment and look at this. Whenever you ask your calculator to find a value, a zero, a minimum, a maximum, a point of intersection, any of those 5 things right there, whenever you do one of those 5 things, and we just did one of those 5 things, we just intersected. It's off the screen at the moment, but we did. We intersected these two graphs. When you do that, the calculator is automatically going to store the x value that it computed as x and the y value that it computed as y. Let me go ahead and intersect one more time just so I can see those values on my screen. Enter, enter, enter. Okay, so we should have right now 0.9990834 stored in x, and probably with even more decimal place accuracy than what we're seeing displayed right here. And then the y value, 4.712389, should be stored in y. So let's check and see if that's true. I'm going to quit, second quit. I'm going to clear my home screen. I'm going to clear my key press history. And let's just see. Right now, if I press X, enter, sure enough, it remembered what that x value was. So it's right there. It's stored in x for me. I don't have to even store it actually manually. It's already there. And let's see what's in y. So if you want to get to any of the letters, like y is right here on the number 1 key, but notice that it's in green. So you would hit alpha and then press that button, and that's going to give you y. And then hit enter, and there's our y coordinate. So x and y automatically get stored in x and y. So this is really useful. So that if you're trying to now evaluate the function at that x value, or any function at an x value where you've just found a solution, you can just press the letter x on your calculator, or the letter y if you need the y value, and use that instead of having to type out that long number and round it. The problem is every time you go back into that calc menu and find a new point of intersection or a new minimum or a maximum or a zero, it's going to overwrite those values. It's going to put the new x value and store that as x. So oftentimes it's safer to go ahead and store it manually as something else besides x. So to do that, we can just say, let's take x and store it. So I'm going to hit the store button, which is right above the on button here. Store it in another letter, whatever you want. I like to use the letter A because it's really close to the alpha key, and it's easy just to press alpha A and then hit enter. And now that value is stored in A. So anytime I hit alpha A, enter, that value is going to come up, and that will not be overwritten until I manually overwrite it. So now if I go back in with a new function and get a new point of intersection, the calculator will automatically overwrite what's stored in X, but it will not overwrite what's stored in A until I specifically do it myself. So that's really nice. So we're going to store that. I don't know that we need to store the Y value in the coming questions, but we can do it just for practice. So I'll call up Y using alpha 1, hit store, and I will save that as B, alpha B, and hit enter. So now if I need that value, I can just hit alpha B and use that instead of typing in the value. Okay, so let me clear that, clear my history, and let's move on. So we stored our value in A. What is the significance of A? So that was that number. What was A? Let's bring it up again. 0.999083496. That is where our function f of x has its vertical asymptote. And the reason for that is because if we go back to this y1 equation, this is a tangent function, and the tangent function has a vertical asymptote whenever the inside, the thing you're taking the tangent of, which is called the argument, whenever the argument is equal to pi over 2 or negative pi over 2, or those values repeat every pi units because the period of the tangent function is pi. So if you have a vertical asymptote at pi over 2, then you also have a vertical asymptote at pi over 2 plus pi. If you just add the period to one solution, you get the corresponding solution in the next cycle. So for us, this pi over 2 plus pi would represent where this tangent function has a vertical asymptote. So that was a little bit complex way that we went about. It's like a clever way of finding where that asymptote was to know that the tangent function would have to have an asymptote at pi over 2 or pi over 2 plus multiples of pi or minus multiples of pi. Okay, so let's verify that. Step 14, go back into our equation editor, turn on y1. So we're going to highlight the equal sign and hit enter to turn that back on. And then it's telling us to go ahead and clear the equations in y2 and y3. Oh, let me move my cursor over here. Clear. Clear. Okay, there we go. So we're back to our original function f of x being in y1. And I'll clear that as well. Number 15, find f of a. So f of x is stored in y1. I'm going to use the F4 menu, but we talked about different ways you can do that. And I'm going to find y1 of, instead of typing the number, I'm just going to call it up as a. And when I do that, I get an error, which is what I'm expecting because there is a vertical asymptote there. So there is no function value that exists at that a value. Now, if I hadn't used a, if I had actually typed the value, and I don't remember what a is, so let me just get it on the screen here. Okay, so let's try this again where I'm just typing it. So now I want y1 of, and I'm going to type it manually, 0.9990834.096. And we'll see if that produces an error. That does not produce an error. So it's really important sometimes to be able to store values without rounding them. If you just type in the value, even as many as 10 decimal places, that's going to give you unreliable results because this does not indicate that there's a vertical asymptote. Although you might say, well, that is such a big number, it looks like it's approaching infinity. You still might be able to make that conclusion that there's an asymptote there. But this doesn't really definitively show us that there's an asymptote there. It just means the graph has a really high y value at 0.990834096. Because the actual value of a goes beyond that. It has more decimal place values than what we're seeing at the end of this number here. So being able to store a value and not rounding it when you're working with calculations can be extremely important. Okay, number 17, find the x-intercept for f of x. So this goes back to the fact that we're trying to sketch this graph on paper. So we know what's happening at the endpoints. We know where to draw our vertical asymptote. Now we need to figure out where to put our x-intercept. Let's go back to the graph for a moment. And you can see that there is an x-intercept here. My window is set on the interval from 0 to 1, so that's maybe 0.7-ish. We'll be able to find it. If we go into the calc menu and choose number 2, 0, finding zeros. So you just need to move your cursor until it's a little bit to the left of the 0. It already is, so I'm going to leave it where it is and hit enter. And then you just move your cursor until it's a little bit past the 0 and hit enter. And that sets like a subinterval, boundaries. And the calculator is going to look between those two boundaries, where does the function equal 0? So then hit enter, and it gives us that value. So that value is stored in x right now. I can, if I need to store it permanently, I can store it in a or b or c or any of the other letters besides x or y. but I don't think that we need to do that. Actually, step 18 does ask us to do that. Store this value in B and verify that f of B equals 0. Okay, so right now that value is x, and we're going to take that x value and store it as B. So alpha B, enter. That is our x value of our y-intercept. Now let's verify f of b equals 0. So we'll bring up y1. I'm going to go into the F4 menu. y1 of b, enter, and it is in fact 0. So now we have our x-intercept that we can add to the sketch of f of x. Okay, so finally, number 19, use all of that information that we found to graph y equals f of x on the interval from 0 to 1. So mission accomplished. And we do have just a couple more questions left just to show you some other tips on the calculator that you may find useful. So let me clear my home screen, clear my key press history, and let's take a look at some of these. Find the slope of the line passing through the points 0f of 0 and 1f of 1 using the slope formula, where you subtract your y values, subtract your x values, and set up that ratio. So to bring up the fraction template, we're going to go into the F1 menu. So hit the green alpha button, F1, and then choose number 1 or just hit enter. The n over d is numerator over denominator. We get that little template that we can type into. So y2 minus y1 is really going to be f of 1 minus f of 0. So I'm going to use my F4 menu to get f of 1. So y1 of 1 minus, and then I'm going to do that again, going to F4 to bring up y1 of 0. Arrow down to move into the denominator, and the x2 minus x1 is just 1 minus 0. And then I can hit enter. Okay, so pretty easy. The fraction template is convenient. If you don't use the fraction template and you're trying to do your calculation all in one go, you end up needing to use a lot of parentheses, and that can cause some errors and frustration. All right, does the answer make sense graphically? So we're finding the slope of the line through 0f of 0 and 1f of 1. If we look at our graph, 0f of 0 is this point on the left here. And then 1f of 1, remember on the graph, it looks like at 1 that the graph's going to be up here, but actually it was at negative 170. It was like way down here somewhere. So yeah, I would say that does make sense for our slope. It doesn't look like that's what it should be in our viewing window, but we do know a little bit more about what's actually happening on the graph there, so it makes sense. Okay, number 21, finally we want to find the slope of the line passing through the points 0.4f of 0.4 and 0.5f of 0.5. The most efficient way to do this is to recall the formula we entered in the previous step. So instead of starting over, bringing up the fraction template, typing, I'm just going to use my history. And to do that, I hit second, enter. And that will bring up the last command that I used. And if you do that again, I don't really want to do that again because this is what I want, but just to show you, if you keep doing that, second, enter, then it's going to go back, like cycle through your history, second, enter. So it's going back and showing me all the things that I've entered. So I'm going to clear that, and I don't know what's going to happen if it'll give me what I want here. Second, enter. No, it's still going back through my history, so I kind of messed that up for myself. But I can arrow up, highlight this, hit enter, and that will also bring it back up, an editable copy of the work that I did there. So we need to change some things, and this is a really great tip. I saved a really good one for last, guys. A lot of times I see students do something like this, and they missed parentheses or they have to go back and add something, and when you start typing, it types over what's there, and students get frustrated and they just clear the whole thing and start over. You don't need to clear the whole thing and start over. You can insert. Look at your delete button on your calculator. DEL for delete, but above that it says INS, and that stands for insert. You can insert without overwriting what's there. So you can add to what's there without overwriting what's already there. So we need this to say 0.5 instead of 1. So I'm going to type the 0. So normally you start typing, it writes over top of it. If I type a decimal point, it's going to get rid of my parentheses. I don't want to do that. I want to insert. So I'm going to hit second insert and then type the 0.5. And it just inserts that in there without messing up what's already there. And then I can arrow over here, and I need this to be a 0.4. So 0, and then I'm going to insert 0.4. And then on the bottom, I need 0.5 minus 0.4. 0.5 minus, and I can just type over what's already there. And here is my estimate for that slope. Does this answer make sense graphically? So between 0.4 and 0.5, if we look at the graph, 0.4 and 0.5, we're really just kind of working, we're going from maybe this point right here on the graph to this point right here. So the slope is positive, that makes sense, and it's pretty small, it's a small number. So yeah, I would say that does make sense. Okay, so that's it for my calculator tips and tricks. I hope you have found some shortcuts and some things that will make using your calculator easier for you this year in calculus. Good luck, guys. See you next time.